question for the
Okay, in our last lecture, we solved systems of equations. That's two equations, two unknowns, both lines. We solved three linear equations with three unknowns. And we did it by the determinant method. Now, the determinant method is an alternative method of solving systems of equations. Now, the determinant method is the way the computer operates in solving systems of equations. So you have these various methods at your disposal now. So when you have the test, I'm not going to say solve by this method. You use the method that's most comfortable for you, that you have the most confidence with. This is it. Okay? So let's go on. Today, a very nice, easy day. On the board, I have an equation. X squared plus y squared is equal to 26. What would be the geometrical representation of this equation? What would it be? Help. Somebody. What would that be? Remember, all the, you're going to be tested on these next week, so you better know them. What would it be? Lynn?
an ellipse.
Nope. An ellipse, A, B, and C must have same sign. A does not equal B. So it's not ellipse. A, B, and C have same sign, but A equal B. So what is it? Circle. It is a circle. So we have a circle. Let's take a look at another equation. X plus y is equal to 6. What would be the geometric representation of that equation? Line. So we have a circle and a line. Now if I graph the circle and the line on the same set of axes, if I draw this circle and this line on the same XY plane, what are the possibilities of intersection? 2 points? Yeah, we can have. If we have a circle, we have a line, we can have 2 points of intersection. 1 point? Sure. We can have a circle and we can have a line tangent to this circle. 1 point. Or none. In other words, we can have a circle and then we have a line nowhere near that circle. Now, you have to remember, when we have these points of intersection, it's going to be a point. That means it's going to be an order pair XY. And this order pair is going to be on both of these figures. This point XY is going to be on the circle, and its same XY is going to be on the line. Now our job is to find this point of intersection. Well, we can graph it. We can graph the circle, we can graph the line, and we can find it, but it might not be too accurate. So you see what we have here is we have two equations, two unknowns. As I often stated, we don't know how to work with two equations, two unknowns. The only thing we know how to do is operate with one equation, one unknown. So with the algebra skills we have developed, we somehow have to get one equation out of this, one unknown. So what we're going to do is we're going to go to the line, the equation of a line. X plus y equals 6. Equation of a line. What I'm going to do is I'm going to solve this for one of our variables. Doesn't make a bit of difference which one in this case. Always the easiest one, but they're the same, so we can solve for either one. So let's suppose I solve this for x. What would x equal? Nope. What would x equal? We're taking this equation and solving it for x. What's x going to equal? 1?
Minus 6.
Nope. What's x going to equal? 6? Nope.
6 over 1?
6? Nope. Nope. I'm going to solve this for x. Remember what we mean by solving it for something. We want to get it all by itself. That's the name. That's what we mean. When we solve for a letter, we want to get that letter all by itself. So I want to solve for x. I want to get x all by itself. What would x equal, Kathy? Oh, come on. We had this time and time and time again. 6 minus y. Okay? We want x all by itself. We want to get everything else off of there. So there is the value of x. Now notice, we are looking for the point of intersection. There it represents the x on this line. X is equal to 6 minus y. That's our x. But the x on the line is the same x as on the circle. Same x. So if I take my circle, every place I have an x, I put in its value. Notice this x. See, this is our xy. This x is that x, and this x is also this x in a circle. So now if I replace x by its value in our curve, I come out with this is x, well that's 6 minus y squared, plus y squared equal 26. All I have done was replace x by the value we said that x is equal to. Notice what we have. We have one equation. We have one unknown. The only thing we have in this equation is y. That's the only variable we have now. We can handle any equation with one variable. Well, the first thing we have to do is square that binomial. Remember the first week of class? I told you the last week of class we're going to be squaring binomials. And as you go on in math, no matter how far you go, you're constantly going to be squaring binomials. Well, if we square this, we get 36 minus 12y plus y squared. This is what we get when we square the quantity 6 minus y. Plus y squared equal 26. Combining like terms and putting this in proper sequence, I have 2y squared minus 12y plus 36 equal 26. So there I come. Notice what kind of equation I have. I have a quadratic. But we know that anytime we have a quadratic, we have to get it in general form. That means we have to get everything on the same side. You have to get this equated to 0. So if I do that, I have 2y squared minus 12y plus 10 equals 0. And there's our quadratic equation in general form. Now we can solve this. Remember, we had 3 ways of solving a quadratic equation. They were factoring, completing the square, quadratic formula. You pick whatever method you like to. See if it works. Well, what can we do here to make this a little easier to look at? What can we do? Karen, what would you want to do with this to make this a little easier to work with?
Factor out 2.
What better than that? Let's divide through by 2. This is the equation. Remember, we're allowed to do anything to one side as long as we do the same thing to the other side. So I'm going to divide each term by 2. If I do that, I have y squared minus 6y plus 5. If I divide 0 by 2, I still get 0. Now, if you notice what we have here, these are equivalent equations. You remember the elimination method, we had to build up equations. We had to multiply both sides by some number. Well, stands to reason. If you can multiply every term by something, you can divide every term by the same thing. And that's all we're doing. Now this equation is equivalent to this. It gives you the same answers. But this is a lot easier to operate with than this. As you can see, well, this is factorable. We factor this. We get y minus 1, y minus 5 equals 0. We set each factor equal to 0. We have y minus 1 equals 0. That will give us y is equal to 1. We have y minus 5 equals 0. That means y is equal to 5. Notice what we have. We're going to have 2 points of intersection. In one of the points, y is going to be 1, and the other point, y is going to be 5. This is what it's saying. Y equal 1, y equal 5. So we have the y values of these points of intersection. We have both of those. We have to now find the corresponding x value. Well, how can we find this x value? Lynn?
Y equals 6 minus x, and then do the same thing.
No, well, you could, but I'm not going to work that hard. We know what y is. We have
drop
to.
it in.
Yeah, just plug it in. The question is, where do you plug it in? The easiest place to plug it in is when you solve for x. Right here. Right here, you're going to plug it in. You have this solved for x. So if y is 1, x would equal 5. 6 minus 1. Right here. See how nice and easy it is? If y is 5, x would equal 1. Check it in the first equation. Hey, it works. There are the 2 points of intersection. Okay? So let's go over this. What we're dealing with today are systems of equations that have a curve and a line. A curve and a line. When you have systems of equations with curve and a line, the best way to handle the problem is to take the equation, the line, solve for one of the variables, the easiest variable. In other words, if this was 3x plus y equals 6, if this was 3x plus y equals 6, you would solve this for which one? X or y? Y. Sure. Because if you have 3x plus y equals 6, if you solve this for y, you get y equals 6 minus 3x. That's easy to plug in. If you would have taken the same equation and you would have solved it for x, you would have 3x equals 6 minus y. X would equal 6 minus y over 3. You'd be dealing with fractions. And then you're going to have to square it and everything else. So always solve for the easiest variable, the one that gives you the least amount of difficulty to solve for. Once you solve for this variable is the same in the line as it is in the curve. So you go back to the equation of the curve. Every place you have this variable you solve for, you replace it by its value. You will have one equation, one unknown. 95% of the time, 19 times out of 20, this will be a quadratic. Okay? You solve the quadratic, find the values for that particular variable. Once you have that variable, you come back to the equation line where you solve for the variable, plug it in. Let's try some. On the board I have an equation. It says x squared plus 2y squared is equal to 9. What does this represent? Ellipse. Very good, Kathy. Ellipse. So we have an ellipse. And let's see, the second equation, let's have it x plus 2y equal 5. That is a line. So we have an ellipse. We have a line. We like to find the point of intersection of this ellipse and line.
I'll let Ian run that one. I'll let Ian run that one. Ian will run that over there. After that, I'm on the front. You won't need it. I'll do it on Sunday. That's what I'm going to do.
Notice what we have. We have an ellipse and a line. So we're going to take the equation of the line and solve it for one of the variables. Now, as I say, as far as the answer goes, it doesn't make a bit of difference which variable you solve for. For the simplicity of the problem, it makes a big difference. But as answers-wise goes, you can solve this for x or you can solve it for y and come out with the same answer. You have to come out with the same answers. Now, the easiest variable to solve this for is x. X would equal what?
5 minus 2.
5 minus 2y. Now remember, when these two intersect, these two geometrical figures intersect, this x and this x are exactly the same. And that's what we're looking for. So if we take our ellipse, every place we have an x, replace it by its value, we come out with the quantity 5 minus 2y squared plus 2y squared is equal to 9. Okay? Now, just manipulating, using these your algebraic skills, you have one equation, one unknown. You should have no trouble solving this. If we square this binomial, we get 25 minus 20y plus 4y squared plus 2y squared equal 9. Combining like terms, we have 6y squared minus 20y plus 25 equal 9. Seeing that we have a quadratic, we must equate it to 0. Doing that, we have 6y squared minus 20y plus 16 equal 0. Again, we can divide through by 2. If I do, we get 3y squared minus 10y plus 8 equals 0. And this is factorable. We have y and 3y. We have, let's see now, we have a negative 4 and a negative 2. We set each factor equal to 0. We get y minus 2 equals 0. Y is equal to 2. So we're going to have one order pair where the y value is 2. Setting the second factor equal to 0, we have 3y minus 4 equals 0. 3y would equal 4. Y would equal 4/3. So our second order pair, second point of intersection, is going to have a y value of 4/3. We now have to find the corresponding x value. So we come right up to where we have it solved for x, right here. We plug in the value of y. Well, y is 2. So we get 5 minus 2 times 2. Well, it's 5 minus 4 is 1. The second one I'll work out. So we have x equal, now we're going to use 4/3. So we have 5 minus 2 times 4/3. Well, we get 5 minus 2 times 4/3 is 8/3. Well, 5 is how many thirds? Well, what's the LCD for this? 3. So we get x equal, we have to make each one of our denominators 3. We have 15 minus 8, we get 7/3. And I find that most students have trouble right here with the arithmetic. They'll go perform all the algebra greatly, and then when they get a fraction and plug it in, they make careless mistakes. As you can see, the ratios going out there. Okay? And there are our points of intersection. If you want to check it, go into the curve and plug it in. 1 square is 1. 2 square is 4 times 2 is 8. 1 plus 8 is 9. Check the other one. It will work also. One more. 5x plus y equal 7. This is a line. Both variables, first degree. X squared plus y equals 3. What is that? What geometric figure is